Okay, here we go. Your MDI. Identify each angle pair as either alternate interior, alternate exterior, corresponding, or same side interior. So, for the first one, okay, so if we're looking at angle 7 and angle 6, angle 7 is this one, angle 6 is this one. So if we think about what alternate means, alternate, remember, means on opposite sides of the transversal. These are not alternate, so we can automatically eliminate anything that says alternate in it. Corresponding means that you're taking something from this group of angles and it matches up with an angle from this group down here. Well, 7 doesn't match up with 6. 7 would match up with 5, so can be corresponding. So same side interior. Same side, remember, means they're on the same side of the transversal and they're on the inside of the lines that are being cut. So these would be same side interior. For angles 8 and 4, here's angle 8, here's angle 4. They're on opposite sides of the transversal and they're on the outside of the lines being cut. So these would be alternate exterior angles. And just to recap, these two should sum up to 180, and these two should be congruent. All right, so give you a minute or two to work on your launch. See if you can figure out what the measure of the missing angle would be. Measure. All right, so we know that this line right here is a straight angle, and a straight angle always has to add up to 180 degrees. So these two angles here have to add up to 180. So you can take 180 minus 147 should give you 33 degrees. So x is equal to 33 degrees. Okay, today's the 27th. You should be writing down section, title, and learning goal in your notes. And I also have a note sheet for you. You guys should have that note sheet for today. I think, let me check. Yes, you should have a note sheet for today. Learning goal is I can identify different types of angles, and then we're going to differentiate between supplementary, complementary, adjacent, and vertical angles. There's that vertical angles again. All right. So, just filling it in here, two angles whose measures have a sum, and if you remember, sum means add, have a sum of 90 degrees. This is complementary, by the way. And this is spelled wrong. This should be L-E. That bothers me, sorry. Okay, so down here, it's saying angle WXYZ is blank to angle YXZ. So we know that they're both part of this 90-degree angle. So if we take this angle here and this angle here and add them together, we should get 90 degrees. So we would say that these two angles are complementary. And the way that you would figure out x down here, if we know that these two angles need to add up to 90 degrees and this angle here is 30 degrees, we would just say x plus 30 is equal to 90. So x is equal to 60. I know this is mental math for most of you. Hopefully it's mental math for most of you, but what we want you guys to get used to is not all of them are going to be as easy as this, so we want you guys to get used to setting it up into an equation like this. All right, so if this is complementary, this is supplementary, and we talked a little bit about supplementary yesterday. Okay, so two angles whose measures have a sum, and again, sum means add, so they add up to 180 degrees. So somebody taught me one time that in order to remember the difference between complementary and supplementary, if you take the C from complementary, you can turn it into a 9 for 90, and if you take the S in supplementary, you can turn it into an 8 for 180. So if you have a problem remembering the difference between complementary and supplementary, the C turns into a 9 and the S turns into an 8. Just a little trick for you. So we would say here HIJ is supplementary to angle JIK. And again, in this one we've talked about before, this is a straight angle, and a straight angle has to add up to 180, so x plus 135 is equal to 180. If we subtract out our 135, we get 45 degrees. So our x up here is equal to 45 degrees. So adjacent angles and vertical angles. We've talked about vertical angles before, and we've talked a little bit about what adjacent means. So adjacent is two angles that are side by side. They have a common vertex. Vertex is where the corner is. So they have a common vertex and a common ray. So if we look up here, we have angle ACB and ACD. So these two angles here are adjacent angles because their vertex is at C and they both share the ray CA. They may or may not be congruent. So just because they're adjacent does not mean that they have to be the same. It doesn't mean that they have to be different. So angle ACB and ACD are adjacent. They're neighbors. They could knock on a door or a wall in between their two houses or apartment buildings. Vertical angles, however, we've talked about these a lot before. They're two angles formed by two intersecting lines. They're always, always, always congruent, and which means that they have the same angle measure. So angle LMN, and angle OMP are vertical angles. So if we wanted to figure out, in this little figure down here, if we wanted to figure out what x is, we know that x is the same as this angle down here because these two angles are vertical angles. So x is equal to 115 degrees. And we also know that these two angles right here are vertical angles. And so in order to figure out what y is, we know that y is equal to 65 degrees. And we can check because if we add these two together, it should equal to 180. These two should equal to 180. These two should equal to 180. And these two should equal to 180. All right, so here's where the tricky stuff comes in. So I'm going to give you guys, take a second, pause, write down the examples in your notes. Just write the pictures down with all the numbers, and then we'll go over the problems together. Okay. Slide this up here so we have a little bit more room to work. Okay. If we look at the big angle here, the big angle is a 90-degree angle, and we know that because of the square in the corner. So we know that when we add these two angles together, we're adding these two angles together, they have to add up to 90 degrees. They are complementary. So we would have the first angle is represented by x plus 3, and the second angle is represented by 2x minus 3. And when we add each one of these angles together, so this represents one angle, and this is the second angle, it's equal to 90 degrees. So all we have to do is combine our like terms. So like term here, like term here. So x plus 2x is 3x, and these two right here, this is a positive 3 and a negative 3. Well, 3 minus 3 is 0, so we don't have to do anything else with that. These two are going to add to nothing. And then we still have our equals 90 over here. And to solve the equation, all we have to do is divide both sides by 3, so x is equal to 30, and it's not equal to 30 degrees, it's just equal to 30. So if we wanted to figure out what the angle is, this is similar to what we had to do last chapter. If we wanted to figure out what the angle is, we would take our value here and plug it into each one of these here. So this would be 20 plus 3, so this would be 23 degrees here. And this one would be 2 times 30 minus 3, so 60 minus 3. This angle here would be 57 degrees. So this angle is 57, this angle is 23, and if we take 23 plus 57, ooh, did I do that right? We should get 90, but that's only coming out to 80, isn't it? Oh, that's because this should be a 30. Whoops-a-daisy, so this should be 33 here. All right, so 33 plus 57 is 90. Much better. I'm sure you guys caught that. All right, same thing over here. These two angles now are supplementary. So this is a straight angle. Straight line has to equal up to 180 degrees. So when we take our two angles, angle 1, angle 2, and add them together, 4x plus 6 plus 11x minus 6, they have to add up to 180 degrees. Same thing here, combine our like terms. 4x plus 11x gives us 15x. And we've got a plus 6 here and a minus 6 here. Those are going to go away, they're going to add up to nothing. So 15x is equal to 180 degrees. And divide both sides by 15. So x should be equal to, if I've done this correctly, x should be equal to 12. This doesn't mean that that's our angle measure. It means that we would have to plug this into x to figure out what this angle is right here and what this angle is right here. So if we wanted to do that, we would just do 11 times 12 minus 6, which is, I believe, 132 minus 6. So 126 on this side, and 4 times 12 plus 6 over here, so 48 plus 6 is 54 degrees over here. So if we take 54 plus 126, it should add up to 180 degrees. All right, the third one down here. The first thing that we're gonna have to do is we have to figure out what this variable is right here. And we can't just say, okay, well, this whole thing is equal to 96. We know that these two here are vertical angles, so yes, this is 96, but first we have to figure out what x is, because in order to figure out these two here, we have to figure this one out first. So 2x plus 6 is equal to 96, because we know that vertical angles are exactly the same measure. So all we have to do is subtract 6. 2x is equal to 90. Divide both sides by 2, so x is equal to 45. So that means that this x is equal to 45, so this whole angle right here is 45 degrees. And if this side is 45 degrees, because these two are vertical angles, we know that this one is also 45 degrees. And we don't even have to plug this in. If we were to plug this in, we would know that this angle right here is 96 degrees also. And if we were to add these two together, oh, that's not going to work, is it? Somebody made a boo-boo. What should happen is these should add up to 180, these should add up to 180, these should add up to 180, and these should add up to 180. So that's not an accurate representation. Pretend like that didn't happen. Okay. I'm not going to have you guys do the exit slip, but I am going to have you guys do the board problems. So this is the homework. You guys can pause it, and you have the rest of the class for you to work.